Welcome friends. This lecture is continuation of your yesterday's lecture on worm gear drive. Yesterday we have completed up to point advantages of worm gear drives. Now we'll see the disadvantages. If you see the gear material, worm gear materials are expensive, like phosphor bronze, which is used for worm gear or worm wheel. And second part, as you're knowing that worm gear drive reduces very high amount of speed, or it is having very high gear ratio. Power losses are very high in case of worm gear, and also efficiency is low. So it is having very high power losses and low transmission efficiency. And due to this high speed reduction, there is a large amount of friction and a lot of heat is generated. So in these worm gear drives, you are required to solve the numericals on heat generated and heat dissipated, which we have not solved in the case of spur gear and helical gear. Again, power transmitting capacity is low in case of worm gear drives. Now we'll see the terminology of worm gear. Nomenclature or terminology of worm gear, how it is designated. The worm gears are designated by 4 quantities. These 4 quantities are very important. In exam numericals also, you are going to get these 4 quantities. You will be getting this signature, and from this signature, you have to get your number of starts, number of teeth on worm wheel, diameter quotient, or it is called quotient, and module M. So designation for the number of start on worm, that is Z1, or it is ZW. So some authors have written as Z1, one notation is given, and some authors have given W for the starts on worm. Number of teeth on worm wheel, it is designated by Z2 or ZG. Some authors have given number 2, some authors have given G. Now this diametral quotient or quotient of worm, Q, is a very important part, and you are not seen in other gears. This is the new term to you in this worm gear drive. And the next part is module, that is designated by M. Now your signature will be Z1 oblique Z2 oblique Q oblique M, or in some books it will be designated as ZW oblique ZG oblique Q oblique M. The diametral quotient or quotient is given by D1 upon M. Now this one notation is given to the threaded part or worm or threaded shaft, and in some books it is DW. So worm stands for W. So D1 or DW by M module. This is the question. So from this you can make it reverse, that D1 is equal to Q into M. You can get this reverse formula. That is, each circle diameter of threaded part is equal to diameter quotient into module, where D1 or DW is the piece circle diameter of worm, D2 or DG is the worm wheel diameter, piece circle diameter of worm wheel. Now again, there are more parts in the terminologies. There are various number of concepts. Diametral quotient you are seeing just now, that is D1 by M. And the most important part is lead L of the worm. So this lead is very important. So lead of worm is defined as the distance that a point on helical profile will move when the worm is rotated through one revolution. When you move the helical profile by one revolution, that is your lead. It is not like axial pitch. Axial pitch means from one point on thread to the next point on the plane. But it is point on the helical profile. Distance of a point on one tooth to the corresponding point on the next tooth on the same helix. It is on same helix, not on next tooth, same helix. So for this, I will explain this concept visually. So for this explaining this concept, we have to go back to our previous slide. So here you can see it is a triple threaded shaft or worm. So in this triple threaded shaft, your lead is shown here on third line. So if this is first line, second line will be here, second, first, second, third. So on third line you get that lead L. So if number of starts were 2, lead would have been here. For number of starts 2. For 3 it is here. For single start it will be like axial pitch. So this is the lead which is related to the axial pitch. It depends on number of starts. Depends on number of starts. Now the next part is pitch circle diameter of worm wheel is given by d2 is equal to mz2 or it is equal to mzg. So z2 or zg stands for pitch circle diameter of worm wheel, of worm gear. The lead angle lambda or gamma is defined as the angle between tangent to the thread at the pitch diameter and plane normal to the worm axis. So there is again one lead angle, which is the angle between tangent to the thread at the pitch circle diameter and a plane normal to the worm axis. For this also we have go back to some figure. You see the figure. What is the lead angle? So here you can see helix angle is shown here. This is the helix angle from the axis. An angle between that line to the perpendicular line, that is the lead angle.